Alright guys, we're going to try a little bit different format for the video today. Today we're going to go over elapsed time and how we get from one moment in time to another. What I'm going to start with, we have our normal conversion chart. So we have 60 seconds, or S, is going to be equal to 1 minute, or MIN, which is the abbreviation for minute. We have 60 minutes is equivalent to 1 hour, or HR. 24 hours is equal to 1 day. 7 days is equal to a week, which the abbreviation is WK. 52 weeks is equivalent or equal to 1 year, YR. 12 months is equal to a year. And 365 days is equal to a year. Unless it's 2020, and we love this year so much, we got an extra day because it's leap year, and that would be 366. But for this math lesson, just know when they're looking at the number of days in a year, it's going to be 365. Don't worry about that extra day every 4 years. Don't do that to yourself. All right, some of the notes we need to make for this lesson is, that's not right. This should actually be 1/4 of an hour. So what I'm going to do is I'm going to fix my mistake real quick. We're going to have to let this dry, but this will be posted correctly in the classroom. Okay, so every 1/4 of an hour, not half of an hour, every 1/4 of an hour is going to be equivalent to 15 minutes. So if we were looking at a clock, I can use the right purple. Let's see, we'll use this color. If we're looking at a clock, which I'm going to put right up here, my circle stills are still pretty good. If we are looking at a clock, we have like the 12, 3, 6, and 9, or the top of the hour, which is 0, 15 minutes, 30 minutes, 45 minutes. But each of those marks represents 15 minutes, and there's 60 minutes in that hour. So another thing we need to note, because I'm not going to do more of the conversion at this point, you've got the conversion thing given to you for over a week now, but you just need to remember, and you're going to have some problems that are conversion type problems, like converting seconds into an hour or whatnot. Just remember, smaller measurement to a larger measurement, you're going to divide. So going from this column to this column, you would be dividing. Larger to smaller, we're going to multiply. So anything in this column going over this way, we would be multiplying. I'm not going to go over an example problem using that, because these elapsed times problems are the ones I feel you might need a little more help with doing this lesson. If you need help with the conversions, please reach out to me and I can set up a Google Meet with you guys. Okay, so we're going to start with this first problem. Our start time, so think of it like a movie. You sit down with your family, you're going to watch a movie. The start time of the movie is 11:38 a.m. It's a really long movie, or maybe we just took a lot of snack breaks, but the elapsed time is going to be, or maybe we're just binge watching our favorite show. So elapsed time is going to be 3 hours and 10 minutes. So just like a regular math problem, we kind of want to take the minutes and the hours as two separate things. And you want to start with the minutes, because if the minutes add up to 60, you're going to regroup it over into the hours. So we're going to go ahead and start with this problem. When we have our start time and our elapsed time, we're going to add them together. So I'm just going to put ST time plus elapsed time, EL time, is going to give us end. I'm just going to put end. I'm not going to write time. We got this. All right, so we're going to do 11 38 plus 3 hours and 10 minutes. If you notice, I'm not actually going to be doing the colon because I'm not doing a time, okay? We're not saying 11:38 plus 3 o'clock plus 10 minutes. Like, we're not doing that. We're doing 3 hours and 10 minutes. So I'm going to leave them separately. I'm not going to put the colon. So now what I'm going to do is add 10 minutes to my 38, and I get 48. And then I'm going to add 3 hours to this 11. 11 plus 1 would put me right at noon. So noon, it goes over into PM. So I'm now in PM, but I still have 2 hours left. So noon plus 2 is going to be 2 PM. So my end time for this problem is going to be 2:48 PM. Now, if this was the opposite and we were looking at PM instead of AM, then midnight is actually AM, and we would switch it over to AM. So if you're around this 11 o'clock hour when we're looking at these problems, just be careful if you're going back and forth, because you will probably be going the opposite of AM or PM that you're working in. So just be very careful and look at that carefully when you are doing those problems. So the next problem we're going to do is going to be a start time of 7:41 PM. We don't know what the elapsed time is, but our end time is 8:50. So in order to figure out how much time has passed in this, what we're actually going to do is take our elapsed time, or I'm sorry, end time, and subtract our start time. Can we actually see the correlation between this problem and this problem? So let's go back and look. So in this, if we add these two terms together, then we get this time. So now what we're going to do is we have the two end pieces, but we don't have that middle. So we know that we could take this and subtract that, and we should get that. So same thing here. We're going to take that end time and subtract our start time, and we should get our elapsed time. And I ran out of room. So we're going to go ahead and just write L for elapsed time. So our end time was 8:50. And we're going to subtract 7:41. Okay. I know that it would take me 9 minutes to get to that 0, right? I also know that from 41 minutes to 50, it would be 9 minutes. So it works out. So we know that that works. Okay, and remember, I'm doing elapsed time, so I'm not doing a time with the colon. I'm just finding my minutes and my hours. So then I also know that I have 8 minus 7, which is 1. So for my elapsed time, I know it took me 9 minutes to get to 50. So 9 minutes would put me at 50 after. So if I was at 7:50 to get to 8:50, I would need 1 hour. So if I subtract these, I get 1 hour and 9 minutes. And if I think about it logically, I know that I add 9 minutes, I get 50. And then I would get 7:50, and then 1 hour more would give me 8:50. So the last problem I'm looking at, I'm going to push my paper up just a little bit. My last problem I'm looking at, I don't know the start time. I know whatever I was doing, it was for 2 hours and 15 minutes, or 2 1/4 hour. And I know that it ended at 5:30. So what I'm going to do on this is I'm going to work backwards. I'm going to take 5:30. So in the beginning, we added. We added these two terms and we got our last terms. Now what I'm going to do is I'm going to take my end time and subtract, because I'm doing the opposite of what I did on the top. I'm going to subtract the end time. Oh, let's do notes instead of writing my numbers. All right, so end time minus elapsed time is going to equal my start time. Okay, so let me rewrite 5:30. I'm going to subtract 2 hours and 15 minutes. I'm converting this quarter hour, if we remember, quarter hours, 15 minutes. I know that 30 minus 15 is going to be 15. I also know if I'm looking at 15 minutes, if I added 15 minutes to it, I would have 30 minutes. So I know that that works out. And then I have 5 minus 2, so working back. So right now I'm at 5:15. 2 hours prior to 5:15 would be 3:15. So my start time would be 3:15, and I didn't cross the noon hour, so it would still remain PM. Okay, I will take a picture of this and post it onto our classroom so that you have it as a reference as well. If you do need help, please let me know, and I will see you guys all soon.